So we're going to take a look at combinations, and we're going to learn to distinguish between a combination and a permutation. We're also going to find the number of combinations for a certain number of objects, and we're going to use that rule with the counting principle. So if I'm selecting objects with no order, that is called a combination. So a password, it has order. You have to type the letters in the right order, so that's not a combination. If you are trying to unlock a safe, you have to type those numbers in a specific order. That's not a combination. If you are picking outfits out of your closet, it doesn't matter if you pick the shirt or the pants first. So that is a combination. So if I have 4 housemates, Ruth, Elaine, Amma, and Jasmine, and I want to list the permutations and combinations where I select 2 people from the roommate list. Let's compare these. In the permutations, we're going to list out all the ways you can select those people, 2 people out of that. Then we're going to remove any duplicates. In the combinations, order doesn't matter. So look at how many fewer there are. There are 12 permutations because we leave the repeats in there, but there are only 6 combinations because Ruth and Elaine are the same as Elaine, Ruth. So a combination is removing out those repeated sections. So if I want to know if something is a combination or a permutation, let's take a look at that. From a class of 25 students, a group of 5 is chosen to give a presentation. Does order matter? So is there a specific order that people have to give the presentation in according to the information I've been given? Well, the answer is no. So therefore it's a combination. If I look at a starting pitcher and catcher are picked from a 12-person intramural softball team, that one's a little less clear. But if you think about a team, a pitcher has a specific skill set, and so does a catcher. So if you're wanting to select a pitcher and a catcher, that means that you really need to pick them in the right order. You can't pick the first baseman for the pitcher. So for that reason, it's considered a permutation. So order does matter. Let's look at an actual example of the problem. So this time we're going to do a combination. A college instructor gives students 7 projects to choose from. Obviously, order doesn't matter because they don't have to do the projects in a specific order from the problem. A week into the course, each group has to submit the list of projects they're choosing and the order in which they plan to present those projects. They are picking the order, not the professor. Therefore, order does not matter. Use a permutation formula to find the number of ways the group can choose. So if I do the permutation formula, I get 210. But I know that order doesn't matter. So if I were to list all the permutations every time that we pick 3 specific projects in order, we'd be listing 3 projects 6 times because 3 factorial is 6. So we would get a lot of complicated layers when we're using that in part B. In part C, if we want to generalize our result to calculate the number of combinations, then I would be dividing by the number of objects that I'm choosing, which gives you this new formula. And then finally, when I get to the combination rule, this is the formula used for combinations. However, this is not the formula you will type into the calculator because you will use Web 2.0 and you will do the same thing for combinations. So if I wanted to have that situation where I have, I would hit NCR, I have 7 things, 7 projects, and I'm picking 3 projects. That would give me 35. So that's how I use combinations, is I'm going to actually use them in that manner. So an application of combinations would be this type of problem. While studying abroad one semester, Tran is required to visit 10 different cities. He plans to visit 3 of the 10 over the long weekend. How many different ways can he choose the 3 to visit? Well, they're not telling me I have to visit things in a specific order, so I'm going to use a combination. I have 10 possibilities and I'm picking 3. So I'm going to go to my Web 2.0 calculator. I'm going to hit NCR. I have 10 possibilities and I'm choosing 3 out of the 10. So 10 comma 3, which gives me 120, which lets you bypass this middle step and gives you the final answer. So I really encourage you to utilize that calculator. What if I'm choosing a committee? So I have 7 women and 5 men. How many different committees could be chosen with 3 women and 2 men? So that's kind of interesting this time because I'm not just choosing people at random. I'm choosing intentionally for 3 women and 2 men. So I have 7 total women and I'm picking 3 of them. So I would use NCR 7 women and I want to choose 3 of those 7. So there are 35 ways to choose 3 women from the 7 total. Then I'm choosing 2 men from the 5 candidates, which means I have 5 men and I'm choosing 2. So 5 comma 2, and that gives me 10. So I have 35 ways to select a woman, 10 ways to select a man for the committee. So I'm going to multiply those 2 together, and that gives me the 350 different committees. So when you're working with this, what's different about this problem than the previous one is I'm selecting from different groups. I have to choose 3 women. I have to choose 2 men. Those are 2 separate pools of people that I'm selecting from. Now, if I'm designing a calendar, that means I want to raise some money for a charity event, and a sorority plans to sell this calendar with pictures of some of the attractive professors on campus. They need to choose 6 people from a pool of finalists that has 9 women and 6 men. How many possible choices are there if they want to feature at least 4 women? So what's different about this is at least. So at least 4 women could mean 4 women and 2 men, 5 women and 1 man, or 6 women and no men. So I have to find the probability of each. So if I want to choose 4 women and 2 men, this is like the problem we just did. So there are 9 women total, and I want to select 4. So I'm going to go to NCR. I have 9 women. I'm selecting 4 of them. So the number of ways I can do that is 126. Then from the men, I have 6 men total, and I would select 2. So I have NCR 6 comma 2, which gives me 15. To calculate the total number of ways, I'm going to multiply that 126 times 15, and that gives me 1,890. I am going to repeat that for 5 women and 1 man, and for 6 women and no men. Once I have all of those counts, I'm going to add them up to get the total number of possibilities. So that's how we're going to combine combinations in with probability.